Everybody have a good weekend? So, let's see, what's coming up? So yeah, y'all have a test tomorrow. Over all of chapter 1, essentially. I've posted solutions to everything except the 1.6 homework. That'll be posted probably in the morning, if not later tonight. If everybody gets it turned in on time, I can post it tonight. Otherwise, I usually wait till morning. Because once I post solutions, I record zeros. So that's a little bit of grace period. But it's convenient if people don't need the grace period. All right. So that'll be posted. There are some other kind of quick facts things to remember. So if you look at those documents on Canvas, it has all the kind of graphs that show up routinely. It has another one on indeterminate forms. So what the non-indeterminate versus indeterminate forms are, just a list of them. So definitely look at Canvas as you're studying. Make sure you use all the resources that you need. All right. The 1.6 homework is due tonight. So I was going to start by doing a couple problems from the homework that people have asked me about. We will start section 2.1 on Friday, so make sure you prepare for that going into class Friday. Any quick questions, anything? So the exam will start right at the beginning of class. It's roughly 3 times the length of a quiz. So you get the entire class period. All right. So make sure you show up on time, ready to go. It's borderline long. I don't think it's too long, but if you spend forever looking at one question instead of going to the rest of the test, then it would be too long. So make sure, use your time wisely when you look at the test, but then also make sure you get here on time. All right. All right, so a couple questions people asked me to look at. First one, let's look at number 51. So first time I'm not going to do 51. We're going to do one slightly different. It's the same function, but I want to take a limit at infinity instead. And then we'll do the exact one in the homework. So it's x to the negative 1/3 minus x to the negative 1/2. And first I'll do the limit when x goes to infinity. How could we rewrite this one? What do the negative exponents mean? Yeah, it's really reciprocal, right? So I could say this is the limit as x goes to infinity of 1 over the cube root of x minus 1 over the square root of x. What is the cube root of x when x goes to infinity? If I take the limit x goes to infinity of this part, what would I get? Yeah. So cube root of x looks like this, where it goes up forever. So if I check, this would be 1 over, I can just say cube root of infinity if you want, minus 1 over the square root of infinity. We're using notation a little bit, but what is square root of infinity? Still going to be infinity. This goes up forever. I think the limit's still going up towards infinity. If I do the square root function, it looks like that. Kind of the same idea though. If I were to try to take the square root, it would still look like infinity. So then what is 1 over infinity? What do we write that as, or replace that as? 0? All right. So this is really 0 minus 0, which gives me 0. How do we take limits? What's the first thing we always try? Just to plug in and see what happens? And then we see, do we get some non-indeterminate form where we know the answer? Do we get an indeterminate form like 0 to 0, then we know we need to factor cancel? Is everything nice and I just get a number? Like we have a few cases, right? On the test, the problems are written to work out relatively quickly. So like this is one, I would probably just write this equal to 0. But you want to be able to recognize that efficiently. Right? You don't want to do a lot of extra work or anything else if you can just recognize the non-indeterminate form and go from there. Right? That's really where it's easy to lose a lot of time. Any questions on this one? So the one in the homework is the limit when x goes to 0 from the right. Why does that have to be 0 from the right and not the left?
You can't find the square root of a negative number.
Yeah, when I do the square root function, I can only take the square root of a positive number. So I need to come to 0 from the right, and this part makes sense. Right here. All right, so first get rid of exponents, or negative exponents. So what happens here? If I take the cube root of 0, I'll get 0, right? And really it would come to 0 from the positive side because you take the cube root of a positive number, it's positive. So when I try to plug in 0, I get 0. If I account for the plus sign, is it going to be 0 plus or 0 minus? I'm treating this like a positive. If I take the cube root, it's still positive, right? My cube root function, if I plug in a positive number, it stays positive. So that would be 1 over 0 plus. And then this one would be 1 over 0 plus. What is 1 over 0 plus? Positive infinity. 1 over 0 is going to be infinity or minus infinity. We need to decide is it plus or minus. Right? So positive infinity minus positive infinity. Now what?
I just tried to figure out which infinity would be bigger,
Yeah.
which would scale higher over time.
So this is one that doesn't come up as much. This is still indeterminate. Why do we say this is indeterminate? It's based on what you were trying to do. I don't know what that answer is. Looking at infinity minus infinity, that could be anything, right? If the first one's getting really big, really fast compared to the other one, it would all go to plus infinity. If I'm subtracting something that's getting bigger much faster, this could go to negative infinity. Or in theory, they might tie each other in some sense. So I have to figure out, basically at this point, I don't know an answer, this is indeterminate. So indeterminate means we need to rewrite the problem, do something else. A lot of times it means factor cancel, but factor cancel doesn't make sense unless it's a fraction. So what should we do first? Yeah, if you notice when you were taking limits, which limits were the easiest? If you wanted to maybe cancel, you always wanted a fraction, right? Like, I know this is indeterminate, which means something needs to cancel off, or I need to be able to rewrite it in some way. Usually the ones that were the easiest to compare were actually fractions. Because then you could, if I had the same thing on top and bottom, it goes away. Right? So a lot of times we rewrite the problem, instead of looking at subtraction, we want it to be a fraction. Right? So how can I do that? A common base would say just multiply the two. So here I have x to the 1/3 on the bottom. To get 1 on the top, it would need to be x to the 1/2. Right? Because in some sense, this one cancel. I'm looking for 1 where I started. Then I'd be it would be minus x to the 1/3. Now what? Now if I try to plug in 0, it'd be 0 minus 0 over 0. So it's still indeterminate, right? What could I do? This is probably the hardest homework problem that we have. Still the question of which one's bigger, right? Is x to the 1/2 bigger or x to the 1/3? It's really not like clear. What do you do when you don't know what thing to do? It's like I want to try to factor, but I don't really know what to factor, right? And it's kind of a question of which one's the biggest. The way around that is just factor one of them out. Doesn't matter if you pick the right one or not, it usually works out. So, I'm going to rewrite this. I'm going to factor, we'll just say x to the 1/2 out. What would be left? Can I factor x to the 1/2 out? I picked it randomly. I could have done x to the 1/3. It actually doesn't matter. I want to factor this one out. I had x to the 1/3, right? So that says I need to remove half a power. If I multiply that back through, what would happen? I'd get x to the 1/2 here. When I multiply it here, you would add 1/2, that part would go away. So is that the same thing? So let's say yes. Another way to think of it is multiply and divide by x to the 1/2. What does it mean to divide by x to the 1/2? You can just subtract the power, right? And then when I multiply, I factor it out to the left. Why would I do this? Immediately we have one thing canceled, right? So this is going to be x to the 0 of x to the 1/2 cancel out. If I get this. Why is this in some sense better? What was always making this harder before? The thing on the left and the thing on the right were doing the same thing. Now are they doing the same thing? If I try to plug in 0 now, what happens? This does something, this does not do the same thing. If you can factor something out to get a 1 sitting there, now they're not going to behave the same way. Here, if I plug in 0, this is 0, this is 0, I don't know how to compare the two. There's nothing kind of frozen there. So here I factored one thing out, could have done x to the 1/3, it really didn't matter which one I chose. But by factoring it out, I get something that when I go to plug in 0, this term and the 1 are not going to behave the same way. So now I can start making a decision. Alright, what happens with 1/3 minus 1/2?
Becomes negative 1/6.
Yeah, 1/3 minus 1/2. Common base would be 6, right? So 2 minus 3. So I'd end up with negative 1/6. So if the limit as x goes to 0 from the right, 1 minus x to negative 1/6 over x to 1/3. And if I get rid of the negative exponent, it's a little easier to see. I get this, right? My goal is to plug in 0. I always get worried with negative exponents because I know I'm dividing. I want to make sure I'm dividing by 0 correctly. Dividing by 0 is awful. Didn't you prefer when you said don't divide by 0? It's a much easier rule. Now it's when you divide by 0, you have to decide is it positive or negative. I am using limits, right? If you don't use limits, dividing by 0 doesn't make sense. So what happens? I try to plug in. If I plug in 0 plus here, take the 6th root. Is it going to be positive or negative? Now if I plug in 0, I get 0, right? But do I keep a plus or make it minus?
Here becomes 1 divided by 0.
0 plus, right? When you take a root of a positive, it stays positive. So this is 1/0 plus. Divided by, when I take the cube root, still 0 plus. If you plug in a positive, it stays positive. So that would be this graph. Come over here, it stays above. If you take a cube root of the negative, it's negative. Alright, so what is 1/0 plus? Positive infinity? Over 0 plus? So what is 1 minus infinity? Still minus infinity? Infinity plus 1 is still infinity? Infinity minus 1, still infinity? So I get negative infinity divided by 0 plus. What does that do? It makes it go to infinity, but it stays negative, right? You could write this just as negative infinity, or you could say this is negative infinity times 1/0 plus, if you want to commit yourself. Then 1/0 plus is again infinity. And then infinity times infinity is still infinity. But I had that negative sign sitting there. Alright, all that was to come up with negative infinity. What does negative infinity mean?
That approaching.
This one was going to infinity, this one was going to infinity, but this one is getting there much faster. This hits the vertical asymptote at a much steeper, it gets bigger, faster. This one really wins. When you have infinity minus infinity, that's not obvious. Now this is a problem where we use every skill we have, basically. But sure, technically I did factor cancel. But factor cancel doesn't mean you immediately know the answer. It then meant, okay, now I can plug in and use non-indeterminate forms. So it's one where you use section 5 and 6 together. There are multiple ways to do this. I think every time I do this problem, I write the answer slightly differently. And that is usually the case, especially in homework. There are usually multiple ways you can do some of these, especially when they get long enough. And it depends on how you rewrite it. I could have tried to factor something out at the beginning. It would look a little bit different. I didn't have to do this in-between part where I made it a fraction. The reason I did that is it made it look more like what we're used to of cancel something out and then do it. And later sections, it's always easier if it's a fraction. So looking ahead, I always tend to use this route. But on the test, problems usually work in at most 2 or 3 steps. So we're not going to give you one where you have to rewrite it 2 or 3 different ways before you come up with the answer. That's always the difference between homework versus a test. If you find yourself going down a black hole in the test and we only give you that much space to work, that's not the best way to do the problem. Make sure you didn't make a typo or something where you change the whole problem because it should work out faster. I don't remember if I'm grading that or not. If I do, I hope all y'all get it right. Either that or we'll find out I made a mistake and should have been less definitive. Any questions on that one? So now you all feel confident for your test, right? By picking the hardest one from. Alright, there's another one I wanted to mention. I had a few students ask me about number 83. So we're given a model where it says everything looks like this equation. So all these are constant values, K, M, or positive numbers, A and B are just 2 numbers. Depending on if the problem was you have a string with a weight attached to it, so stretch it, release it, it's going to bounce back and forth, right? Ends up, if you want to know exactly how it goes back and forth, it would follow this type of formula. But then you have to figure out what is A, what is B, what is K, what is M, and then plug in all the numbers. So the idea is we have a spring, and you put a mass on the bottom, and you stretch it, then release. So what's going to happen? First it goes up, right? And then once it compresses a certain amount, it rebounds and goes back downwards. And then once it's stretched itself back up, it goes back up. And it does this forever. Why is it? Why should I know? The problem made a big deal of saying we're ignoring friction. What makes a spring eventually stop?
Drag. Just like it slows down over time.
And what is actually making it slow down is the friction inside the spring. So if you have a frictional force inside, the spring eventually stops and or balances out and stops, right? If there's no friction there, it would actually continue this forever. Why is that represented here? You took sine by itself and never multiplied by anything to make it go to 0, you would just keep doing this, right? And then cosine, same idea. So you take 2 things doing this forever, add them together, they're either going to perfectly cancel, or they're both going to keep doing this, and when you add together, it keeps doing this combined by 0. Okay. So part A said what would be the limit as t goes to infinity? And then you go back to the story, it made a big comment about how without friction, it does this forever. It does this forever. Does it have a limit when t goes to infinity? It'd have to level off to like a horizontal asymptote, right? Would this graph have a horizontal asymptote? So without even looking at the graph, if you know it's doing this forever, what would it mean to have a limit? It would mean it would have to stop and be near that value, right? Or not necessarily stop, but amplitudes keep getting smaller and smaller and basically level off to one part. So when it says it does this forever, can you have a limit? No, there's no single value for it to go to, right? So this limit cannot exist. And the technical reason is it would have infinite oscillations.
Okay, then we didn't do the squeeze theorem.
Only, so there's a difference between this and one that damps.
Okay.
You could have infinite oscillations that damp. So damping would mean it would squeeze into one value and level off. And that would be caused by friction. So without a damping force caused by friction, this just does this forever. I'll graph this in a minute. But does that make sense why, like, intuitively we would say this just happens, or it never levels off, limit can't exist anymore? Which is part of the, explain how this relates to the fact that this equation doesn't take into account friction due to air resistance. Oh, it did say air resistance. It can also be internal friction to the spring. They're ignoring that part also. Oh, physics minor. How many of y'all have taken physics? You take physics the first time, you learn a bunch of stuff, and it's how it works. And you're like, cool, I can model anything. You throw something there, I can tell you where it lands. If you have two balls that hit each other, I can tell you where they both go. Like, they make it sound easy. And then if you ever take the next 100 level up physics course, they basically say, oh, everything you did was wrong, that was a model, we ignored this. So then you spend the whole course adding in friction or some other force. And you redo all the same stuff and you get entirely different answers. And then you take the next level and they're like, oh yeah, we didn't take this into account. And it's still the same thing, you just keep adding more things to the model. And then you realize you don't believe any physics. And then you try to like fix the model where you take into account everything, and then you realize you get a math problem that you can't solve. So that's where we get stuck. And then they're like, you know, if you take this in the lab, it looks exactly like this, almost perfectly. So if you can't measure the difference, we know it's wrong, but who cares? Alright, so the last part of this problem said draw the graph and look at it. So I wanted to graph it one time since I claimed what it looked like. And it gave us values. If you do number 84, it gives you the friction part. And look at that equation, it looks way worse. So this one's square root of 2 times sine. Yep. So that's the graph. Does it have a limit? Does that kind of match our intuition? Now, it's a little more interesting in that if you only had sine or cosine, it would be exactly this. This one actually trends downwards, then back upwards, then downwards, then back upwards. So it's like they have two waves together. But it's still the same idea of it never levels off. And what's happening is you have sine and cosine kind of fighting each other a little bit, which is why you end up with this one other trend also. But it's still the same idea of this never stops. Because it never stops, it can't have a limit when you go off to infinity. Right. So that's number 83. And that supports kind of what we're talking about, right? Now, I did say use graphing. Any other questions anybody wants to talk about or anything? General questions first, then we can look at the homework one if you want.
A removable discontinuity would be considered an asymptote.
No, a removable discontinuity is always this case. And so to be a removable discontinuity, we have to have the limit as x goes to c is some number L, it must exist.
So
And it can't be infinity, like it must be a number.
yeah. So if I had like an habit of thinking of as an asymptote as just anything that gets infinitely close to something that never reaches it, that's the wrong definition. How should I?
Asymptote means it's vertical asymptote means it's blowing up in the y direction.
Okay.
And then a horizontal asymptote means it levels off as you go out forever.
Okay. And if there is a slant asymptote, we don't have to mess with that.
Nope. Nope, that won't come. Technically that comes up in, well, it doesn't directly come up in here, but a slant asymptote would be a graph that does something like this. So that would be the asymptote. So something like this has a slant asymptote. All we would say is the limit when you go off to infinity is plus infinity, limit when you go off to negative infinity is negative infinity. Like we don't specify, it looks like a line in between there. So we're a much bigger picture when we can say this goes up to plus infinity. So we're not as detailed. We'll get more detailed later in class. Yeah, that reminds me. The first page is, I guess, a couple of true-false questions. So similar to what's been on the quiz, similar grading. And then the third one is write a definition. So, and I give you the first part of what the term is, you know, like the setup, but then I need you to finish the statement. Alright, so we had some various ones of that. What are some examples of words that we had to be careful on the definition? One could be, what is a removable discontinuity? It says you have a limit, but it's not the function value. What would left continuous mean? It would mean I have the limit from the left, and it matches the function value. How do we write the definition of a limit? Now it depends. The standard one was what? There is, for all epsilon, there is a delta where if x is in this interval based on delta, f of x is in this interval based on epsilon. And then we could change it of, say I had an infinite limit. For all m greater than 0, there exists a delta greater than 0, such that if x is in this interval based on delta, f of x must be bigger than m. So there's some general statements that we call definitions. I only put one of those on there, but I know a lot of people like to use them, and a lot of what I'm doing is also prepping for the final. So I don't want final exam questions to come from nowhere. They usually put some of these type things on the final. So if you go to page 152, it mentions some of these things. It'll either be definition or theorem. I should be a little careful on that. So like, what's the intermediate value theorem? You have a continuous function on some closed interval a to b. If you give me a k value between the two endpoints for the y coordinates, there must be some c value in the x part where f of c is equal to that. So we go. So I'll give you the setup with the a, b, all the symbols, that first part of like an if statement, and then you just write the rest of the statement almost like fill in the blank. Okay. So I only have one of those on there, but I did want to mention that's on there. Another type of problem we had was always, here's a graph, tell me about limits, tell me about continuity, those types of things. So similar to a quiz, always look at the old quizzes. When I write quizzes, I make them look like exam type problems. And then a couple of pages are always compute, find the limits. Those are the only things we really computed, right? What else did we compute here? Find the smallest delta value, find the biggest delta value, find the smallest n value, depending on which limit definition we're using. So if you go back to like the skill problems, those types of problems where it says, find this, do this, that is going to be the majority of the test, or at least half the test. So it's always a little bit conceptual of, you can do these problems quickly, or just skip them, I guess. Like, here's the graph, write the limit. You don't want that to take forever. You either really know it or you really don't in some sense. If you're not sure and you're trying to come up with it, don't do that the whole time and forget the rest of the test. Okay. But that's where looking at the old quizzes will help for those types of problems. Same with, we've graded, we always have the prep problem and then the two other homework problems, all those solutions are posted. But some of those are big topics, like we usually grade at least one problem in the squeeze theorem, because that's considered a big topic, or intermediate value theorem. Any of those named ones where there was all the examples look the same, definitely look at those examples. Because if that shows up on the test, that tells you how to solve it. We won't necessarily have all of them on there because we only have 50 minutes, but anything where it was a named theorem and all the skill problems look the exact same, that is definitely a good thing to look at. Half the battle on a test is knowing what your answer should look like, so that you're not doing irrelevant work. If you're trying to do the squeeze theorem, what's your main thing to make, what do you really need to show or come up with? Squeeze theorem said, if I want this limit, I can find a function that's bigger and a function that's smaller and show they have the same limit. The one I care about must be in between, must also work. So if you're really going to use that theorem, what do you need to do? You need to find the bigger function and the smaller function. That is most of the credit. If you can justify what those are. But no, when you do squeeze theorem, you need a bigger function, you need a smaller function. Now you have something to work towards. How do you apply the intermediate value theorem? I studied more for the test than y'all, so I wrote it. So I'm a day ahead of y'all. That one says, basically if I'm up here and down here, I have to cross in between. So if I give you a coordinate here, what do you need to show? You need to show one value is bigger, one value is smaller. If I have a continuous function, then I cross. Right? So those, I don't always ask you to write the theorem, but if you're solving a problem based on the theorem, you have to actually verify the things. Right? That whole if statement. But that's the same thing when we posted solutions, that's what we did. So if you know what our solutions look like, you kind of have those in mind. It gives you a template for how to use those results. What are other big ones? Cancellation, I mean, that's the factor cancel idea. We do that all the time. What else beyond that? did a lot and a little at the same time. It's always when you try to say everything we did, it doesn't sound like as much as it was. But part of it's because, like, in 1.6 especially, you see this, every problem is unique in some sense in all the school problems. Oh, another one. Like I said, we did it some of the concepts. We had some, especially more early on, for all a function that has these limits or these function values. That was one of the threat problems where you had that. So we're really hinting at, do you understand what a limit is? How do you show us you understand a limit? Can you use the Epsilon Delta definition? Can you look at a graph and tell us the limit values? If we tell you, draw a function that satisfies this limit, can we do that? Like, can you visualize what this looks like and draw it? Some of that shows up in true false, some of that shows up in quick. But it's really all trying to get at, do you understand what the graph looks like when we talk about limits? Do you understand how to find limits? Those ideas. Any other questions? So don't forget about the homework tonight, and that's hopefully you know what to anticipate from that. It looks like